Hello, audience, for the 35th time. My name is Ronald McCullough, and I'm going to be solving this differential equation. All right, look at that. Look at that differential equation. We're going to solve it. All right. Actually, that's not even the whole problem. Let me write this up there real quick. Actually, that's the differential equation we're going to solve. Okay, you got it. All right. So, this is the differential equation we're going to solve. I'm going to start by saying I don't see in this problem any functions of x. So our solution is probably going to be an implicit solution where I can't separate the variables, but we're going to find that out in just a second. So how I'm going to tackle this problem, I'm going to separate the variables. I'm going to isolate y, get y by itself, and so let's do that. All right, so I'm going to divide by y to the 5th power to begin, and that's going to give me dy over dx equals 1 over y to the 5th power minus 5 y to the 6th power over y to the 5th power. And of course, these two divide into each other. So I'm going to be left with 5y. And so dy over dx is going to be 1 over y to the 5th minus 5y. I need to integrate these so I can get rid of my function here. So I'm going to multiply by dx, right? And then I'm going to divide by this expression. All right, 1 over, right? So that's going to cancel out dx, and that's going to cancel out this from here. So now I can say that dx from here is going to be equal to dy times 1 over 1 y to the 5th minus 5y. Actually, we don't need that one right there. I'm just going to say that is 1 over 5/5. All right. So I'm going to rewrite it again. And instead of 1 over y to the 5th, I'm going to say dy times 1 over y to the negative 5th power minus 5y. And now we can integrate. All right, of course, if we integrate, this is going to give you x. And this is going to be a little bit trickier to integrate. But we're going to do it anyway because we're awesome. All right? And you are awesome. Remember that. You're awesome. So you're going to integrate y, 1 over y to the negative 5th power minus 5y. And it looks kind of tricky to integrate, but we can get through it because, again, you're awesome. All right? So I'm going to start by putting this expression on the numerator, so multiplying it by, well, who was it? Make this to the negative 1 power dy. And this is the same as, because when you have exponents in this situation, that means you're going to multiply your exponent. So you're going to have y to the 5th minus 5y to the negative 1. All right, and that's going to be dy. So then we have this expression. Now, since these are both functions of y, I can legally say that the following is true. 5 times negative y to the negative 1 dy. To take this integral, you add 1 to the exponent and divide it by what the result is. So then you get y to the 6 over 6 minus. And then this is the same as 5 times the integral of 1 over y dy. The integral of 1 over y dy is ln. So you're going to get ln y plus c, of course. All right, so minus 5 ln of y. Hold your horses, I'm almost done. All right, so you're going to get ln of y. And of course, you know, your arbitrary plus c because this is an indefinite integral. All right, since this is equal to that, we're going to have x2 y6 over 6. And I'm going to go ahead and change this to, so that I can have the 6 all the way on the bottom. I'm going to change this to y to the 6 minus 30 ln y all over 6. Because 6 times 5 is 30, and so that I can legally do that. So that would give me minus 30 ln y. All right, let me move this 6. All right, so now we're going to multiply by 6, and that's going to give me y to the 6th power minus 30 ln y equals 6 times x. If I add 30 ln of y to both sides, I'm going to be left with y to the 6th power equals 6x plus 30 ln y. Now, meanwhile, while this is happening, I do have an arbitrary plus c. So I'm just going to add plus c here. And to get rid of y to the 6th power, I'm simply going to take the 6th root of the entire expression. And so my final answer will be y is equal to the 6th root of 6x plus 30 ln of y plus an arbitrary for c. Thank you very much, and have a blessed afternoon.